let's take a look at the essential question: how can the strategy work backward help you to solve a problem with fractions that involves addition and subtraction? An important term you need to know for this lesson is inverse operation. An inverse operation is the operation that reverses the effect of another operation. Addition and subtraction are inverse operations. An example would be that if you start with the number 7 and then add 3, you would get 10. Now if I do the inverse operation of subtraction and I subtract 3, I would be back at 7. So, how can the strategy work backward help you to solve a problem with fractions that involves addition and subtraction? Well, the first thing we need to remember is that the inverse operations of addition and subtraction will undo one another. Another thing we need to know is that if you have an addition equation with a missing number and you work backward using subtraction, you can come to your solution for that missing number. Another important thing for this lesson is that you might want to use a graphic organizer. It can help to organize your thinking. Let's look at a real-world problem. The Diaz family is cross-country skiing the Big Tree Trails, which have a total length of 4 miles. Yesterday, they skied the 7/10 of a mile Oak Trail. Today, they skied the 3/5 mile Pine Trail. If they plan to ski all of the Big Tree Trails, how many more miles do they have left to ski? It is suggested that we use the graphic organizer to help us solve this problem. Here's an example of a graphic organizer you might use to help organize your thinking. You can see that this graphic organizer has a box to list the information you need to find, or the question being asked. It has a box to record what information you need to use, and it has another box of how you will use the information. And finally, it has space to solve the problem. Let's use the graphic organizer to help us solve this problem. First, I need to figure out what information I need to find, or what am I solving for. In the very last sentence, it's asking me how many more miles do they have left to ski. This tells me that I need to find the distance they have left to ski. Next, I need to figure out what information from the problem I need to use. Well, looking back in the problem, I see that they gave me information about the total length of the ski trail. And I also see that they gave me some distance that they've already skied out of that total distance. They've skied 7/10, and they've also skied 3/5. So when I stop and think about this, I'm going to need to use the distance that they've skied, and I'm going to need to use the total distance they plan to ski. The distance that they've already skied is going to be the 7/10 and the 3/5. The total distance they plan to ski is going to be the 4 miles. Next, I need to think, how am I going to use this information? Well, I know that I could work backwards by starting with the total distance. And then I could subtract each distance they've already skied to find the amount they have left to ski. Remember that addition and subtraction are inverse operations, so by working backward and using the same numbers, one operation is going to undo the other. So if I use the information from the problem, I can write an addition equation. I know that they skied 7/10 of a mile yesterday, and they skied 3/5 of a mile today. But they have m miles left to ski in order to ski the total distance of 4 miles. If I were to work backwards, I would take the amount that is the total distance and I would subtract each of the distances they've traveled. The distance they traveled yesterday and the distance they traveled today. When I do that, I will come up with the distance they have left to travel. I'm going to start with 4 minus 7/10. 4 can be turned into a fraction by putting it 4 over 1. I have 4 wholes. These denominators are not common, so I need to find common denominators. I know that 10 and 1 both have 10 as a common multiple. 1 times 10 is 10, so I also have to multiply the top by 10. 10 times 1 equals 10, so I have to multiply the top by 1. So now I have 40 minus 7 is 33 over 10. Remember that that was just the first 2 numbers of my subtraction problem. I now need to subtract 3/5. Now I'm thinking that I need to find a common denominator for 10 and 5. I know that 5 and 10 both have 10 in common. 10 times 1 is 10, so I need to multiply the top by 1 as well, so I get 33. 5 times 2 is 10 on the bottom, so I also need to multiply the top. So I have 33 minus 6. 33 minus 6 is going to be 27 over 10. This is an improper fraction. I could also write it as a mixed number by saying 2 and 7/10. So after working backwards, I know that the family has 2 and 7/10 miles left to ski. It is always important to evaluate the reasonableness of your answer. This just means that you need to explain or think about how you know your answer is reasonable. There are many different ways that you could do this. One way is that you could estimate the answer and compare the estimated answer to your actual answer. Another way is to compare your answer to the total that you were working with. So if I were to use that strategy, I remember that the total distance of the trail was 4 miles. My answer was 2 and 7/10 of a mile. I could say that my answer is reasonable because the unknown distance of 2 and 7/10 mile is less than or a smaller distance than the total that they started with, which was 4 miles. Let's look at another problem. As part of their new study of Native American basket weaving, Leah's class is making wicker baskets. Leah starts with a strip of wicker 36 inches long. From the strip, she first cuts one piece but does not know its length, and then cuts a piece that is 6.5 inches long. The piece left is 7.75 inches long. What is the length of the first piece she cut from the strip? Remember that a graphic organizer can help you to organize your thinking. First, I'm trying to figure out, what do I need to find? What am I solving for? Looking back in the problem, I remember that it was asking me to solve for the length of the first piece she cut from the strip. Next, I need to look to figure out, what information do I need to use to solve this? Well, I know that it gave me the information about the total length of the strip. I also know that it gave me 2 lengths one for that piece, 6.5 inches long, and one for this piece, 7 3/4 inches long. I don't know the length of the third piece. That was that first piece she cut. Now I need to think, how am I going to use this information? Well, I know that the total length was 36 inches. And if I put those three pieces together, I would get 36 inches. If I use the inverse operation of subtraction and work backwards, I would be able to solve for that missing piece. So I'm going to find that missing information by working backwards. So starting with the equation, I had the first piece I don't know the length of. I had the second piece that she cut, which was 6.5 inches long. And then I had the third piece, which was 7 3/4 inches long. And when I put those three pieces together, I have the total length of 36 inches. I'm going to work backwards by starting with that total, and I'm going to subtract the pieces I do know. So I'm going to subtract 6.5, then I'm going to subtract 7 3/4, and that should then give me the piece that is missing, the piece that I don't know. When I start to solve this, I'm going to take a second to figure out which two numbers I want to start with for my subtraction. I think what I'm going to do is I'm going to start with 36 and 7 3/4. I'm going to take out one whole from 36, which is going to leave me with 35. And that one whole I took out, I'm going to turn it into a fraction, and I'm going to match that fraction up with the fraction of 7 3/4. I chose the 4 because now these two numbers, or these two fractions, have a common denominator. When I subtract 35 4/4 minus 7 3/4, I'm going to end up with 28 1/4. Now I have left to subtract 6 1/2. These do not have common denominators, so I'm going to need to change that before I subtract. I know that 2 and 4 have 4 in common. 4 times 1 equals 4, so 1 times 1 on the top. 2 times 2 equals 4, so I need to multiply by 2 on top. I can now rewrite this as 28 1/4 minus 6 2/4. As I start to look to subtract this, I stop and I think for a second. This is a 1 minus 2. I can't do that. So I'm going to rewrite this one more time by going next door and renaming this fraction. I'm going to have 27, and I'm going to take that whole that I borrowed, and I'm going to add it in. So it's a 4/4. So 4 plus 1 is 5. The denominator stays the same. Now I can do my subtraction. 5 minus 2 is 3. 4 on bottom. 27 minus 6 is 21. This tells me that the length of the first piece cut was 21 3/4 inches. Remember that you want to ask yourself, is your answer reasonable? Well, I think that my answer is reasonable because 21 3/4 is less than 36. I also can think that the other two pieces were 6 and 7. If I add those together, that's about 13. 13 plus 21 is still going to be less than 36. So I think that my answer is reasonable. Let's look at number 3 together. A pet store donated 50 pounds of food for adult dogs, puppies, and cats to an animal shelter. 19 and 3/4 pounds was adult dog food, and 18 and 7/8 pounds was puppy food. How many pounds of cat food did the pet store donate? First, I'm asking myself, what am I solving for? What do I need to find? I know that I need to find how many pounds of cat food did the pet store donate. Looking at the problem, now I'm asking myself, what information can I use to help me solve? Well, I know that the pet store started by donating 50 pounds. That was their total amount. I know that out of that 50, 19 and 3/4 pounds was adult dog food. Out of that same 50 pounds, 18 and 7/8 pounds was puppy food. There's some missing amount that represents the amount of cat food. Finally, I need to think to myself, what strategy do I want to use to solve for this? Again, I could start by thinking, well, I know the total amount, and I know that there are 3 parts that add up to equal it. I could work backwards using subtraction from that total to solve for the missing amount of food. Let's start by writing the equation. I know that I have 19 and 3/4 pounds plus 18 and 7/8 pounds plus a missing amount, which represents the amount of cat food. And when I add all that up together, I have 50. So if I start with the total and I work backwards by subtracting, I should solve for x. I'm going to start by doing 50 minus 19 and 3/4. I'm going to go ahead and change 50 to 49, and I'm going to take that whole I just borrowed and turn it into the fraction of 4/4 minus 19 and 3/4. 4 minus 3 is going to be 1, so 1/4. And 49 minus 19 is going to be 30. Now I have to subtract 18 and 7/8. I need to find a common denominator for these two fractions. I know that they both have 8 in common as multiples. 8 times 1 equals 8, so I need to multiply 7 by 1. 4 times 2 equals 8, so I need to multiply the top by 2. So I have 30 and 2/8 minus 18 and 7/8. Again, I see that this isn't going to work because I have 2 minus 7, so I need to rename this fraction. I'm going to rename this fraction by rewriting 30 as 29 and taking that whole and turning it into 8/8 to represent that whole. 8 plus 2 is 10/8 minus 18 7/8. Now I have 10 minus 7. 10 minus 7 is 3/8, and 29 minus 18 is going to be 11. I know that the pet store donated 11 and 3/8 pounds of cat food. I think that this answer is reasonable because I started with 50 pounds and I subtracted 19 and 3/4, 18 and 7/8. I think that 11 and 3/8 is a reasonable answer. Let's look at our final problem together. Thelma spent 1/6 of her weekly allowance on dog toys, 1/4 on dog collar, and 1/3 on dog food. What fraction of her weekly allowance is left? I'm going to start by thinking what this problem is asking me to find. What is it asking me to solve? Well, I can see that it's asking me to solve the fraction of her allowance that's left. Next, I'm asking what information in the problem can I use to help me find that? Well, I know that she uses 1/6 of her weekly allowance on dog toys. She uses 1/4 of that weekly allowance on dog collars and 1/3 of the weekly allowance on dog food. I know that when I add all these up, including the piece I don't know, I should get her whole weekly allowance. That's just one weekly allowance. It's not a dollar amount, it's just her one weekly allowance. Finally, I'm going to ask myself, what strategy could I use? Well, if I'm going to start with one weekly allowance and I'm going to subtract each of the pieces she spends, that should leave me with that missing amount of her weekly allowance. I'm just going to start by working my way down the line. So I have 1 minus 1/6. Well, I'm going to write my whole as 6/6. That way I have a common denominator. 6/6 minus 1/6 is 5/6. I'm going to go to my next number that I need to subtract. I have 5/6 minus 1/4. I need to find a common denominator for this one. I know that 6 and 4 have 12 as a common multiple. 6 times 2 equals 12. 5 times 2 equals 10. 4 times 3 equals 12. So 1 times 3. 1 times 3 would be 3. So 10 minus 3 is 7 over 12. I'm now going to be doing 7/12 minus my final number of 1/3. 7/12 minus 1/3. I know that 3 and 12 have a common multiple of 12. So that means I can leave my top one the same. It already has 12 as its denominator. I just need to change my bottom fraction to have a denominator of 12. So 3 times 4. 7 minus 4 is 3. So I have 3/12. I know that I could simplify that. Both of these could be divided by 3, which leaves me with 1/4. So what fraction of her weekly allowance is left? 1/4 of her weekly allowance. All right, it's now your time to practice independently. Go ahead and return to the slides for your I and K and access your independent practice that you can be working on.